So, should the self-driving car drive over the father or should it drive over the daughter? That's the classic question regarding self-driving cars, artificial intelligence, and the technology future ahead of us. My name is Mikko. I work for F-Secure. And since this is the 20th Black Hat, the organizers asked me to take a look at the next 20 years. We've seen a pretty wild ride over the last 20 years. Since 1997, technology has changed remarkably, and as we might guess, it's going to continue changing remarkably in the future as well. So I'm going to try to forecast what's going to happen over the next 20 years, although the title of the talk is not 2037, it's 2038, which is 21 years in the future, but we'll get to that in just a moment. And the good side about speaking something 20 years in the future is that I will be 66 years old in 2038. So with any luck, I'll still be alive, and we can all gather around to Black Hat 2038 and look at how wrong I was about the forecasts. Because time travels fast, especially on the internet, time travels fast. Let me give you an example. 10 years ago, every single one of you had either a Motorola or a BlackBerry or a Nokia in your pocket. And today, none of you have any of those in your pocket. And that's just 10 years, right? 10 years. That's not a long time. But on the internet, it is a long time. So what happened 10 years ago? Well, pretty much exactly 10 years ago, Apple released iPhone, and the world changed. And now the world is different because of that. In fact, 10 years ago at Black Hat, at 2007, I was speaking here about mobile devices. My talk title was State of the Cell Phone Malware in 2007. This is my actual slide from 10 years ago. Look at the mad PowerPoint skills I had. Remarkable. I'm so proud. Let me just show you one slide from there. This is statistics of the mobile malware we had found by year 2007. And the platforms I list are Palm, Pocket PC from Microsoft, Symbian from Nokia, and Java. I'm not mentioning Android, I'm not mentioning iPhone. Android isn't out yet 10 years ago, and iPhone had just been released. So what's going to be the future? We'll look at different categories. First, let's talk a little bit about the future of computers. So what's the thing about 2038? Well, I guess most of you know what's going to happen in 2038. If you don't, I suggest you take your phone from your pocket and try to change today's date, the date in your settings, to 2039, for example. And it turns out you can't do it. You can't do it with your current iPhone or with your current Android. And this is the Unix epoch bug, also known as the Epocholypse, which really is a simple bug. It's been there for decades. The bug is just a limitation because originally the the variable reserved for time was said to be a signed 32-bit integer, and that counts seconds from 1st of January 1970, which means we will run out of bits. And it's going to happen in 2038 on January 19th at 3 a.m. in the morning. That's when stuff starts to happen. And of course, this reminds us of an incident which happened 17 years ago, Y2K. And Y2K was a big deal. Those of you who were working 17 years ago in computing remember it was a big deal. I remember spending the New Year night, through the night, on the phone, speaking to our offices and partners around the world, starting from New Zealand as day switches over to 1st of January 2000 to check if everything's working all right. And just to illustrate how paranoid people were during the turn of the century, you could actually buy magazines which would tell you how to survive the crises of Y2K. Doomsday 2000. And then, when 2000 arrived, on 1st of January, every newspaper was writing articles about how this was all a dud, and how nothing happened, and how we wasted all this money and nothing happened. And that misses 2 points. The first point it misses is that there was so much work done before Y2K, during the years and months before Y2K, fixing real bugs. The fact that most bugs were fixed is actually a success story, not a failure, because real bugs were found and fixed. I know this firsthand. And then the other thing they missed was that not all problems show themselves right at the midnight. For example, in UK, there was a major problem with healthcare systems because of Y2K problem in computers, because of computers which couldn't handle the year being 4 digits, because they were only saving 2 digits. And the particular problem, the worst problem they had in UK healthcare, was a problem regarding risk assessments for pregnant mothers regarding whether their unborn baby had the Down syndrome or not. So they gave wrong answers to pregnant women on this. And as a result, babies were aborted. Healthy babies were aborted because of Y2K, which is a pretty big deal. But of course, this was only found out months later. So the news articles written on the 1st of January have no idea about the problems that were found. And mark my words, even though 2038 is still way, way in the future, I will guarantee to you we will have problems. We will have 2038 problems exactly in the same way as we had Y2K problems. And there will be a massive effort to try to fix everything. You think we have a lot of time to do it? I'll guarantee to you we will run out of time. So what about the future of the net? We know that everything's going online. If you look at numbers from Gartner, we'll see massive growth in, not actually in computers going online, but in mobile devices going online, and especially IoT devices going online. One remarkable figure is how many iPhones has Apple sold over the last decade. There's 7.5 billion people on the planet. Apple has sold 1.1 billion iPhones over the last 10 years. 1.1 billion iPhones. And the thing that really fuels devices going online is because of this guy. This is Gordon Moore, father of the Moore's Law. And typically when we speak about Moore's Law, we emphasize how it talks about how the computing power doubles every 18 months, or the amount of transistors we can put on a chip doubles every 18 months. But you can also look at the other way around. You can also look at it, what's going to happen to the price of existing computing power. The price of existing computing power halves every 18 months. And what that means is that the price for that one chip that you have to add to any appliance to turn it from a dumb appliance to a smart appliance, the price of that chip is going to be eventually 2 cents, or 1 cent, or half a cent. It's going to be so cheap that all vendors will add them to all appliances because they want to collect data. So very quickly we will see an era of IoT where consumers have no idea that the device they bought is an IoT device. It doesn't look like an IoT device. There's no app, there's no screen, but it's still online. And it might not be going online using Wi-Fi. It might be going online using LTE-M or 5G or LoRa or any of these future wireless technologies that are already becoming a reality. And we are seeing smarter devices. I am the father of the Hyppönen law, which is that if something is described to you as smart, what you should hear is that it's vulnerable, right? So, smartphone, vulnerable phone. Smart watch, vulnerable watch. Smart city, smart grid. Well, you get my point. And smartness is not really a property reserved to humans alone. Animals can be smart, machines can be smart. Artificial smartness, also known as artificial intelligence, is a great example on how we keep moving the goalpost. In the 1970s, when we were building artificial intelligence, one goalpost we set for ourselves is that when computers are able to beat humans in chess, then we have artificial intelligence. Then when it actually happened, a decade ago, in May 1997, when Deep Blue beat Kasparov in chess, then we suddenly decided that, well, actually, no, that's not artificial intelligence. That's just, a lot of computing, a lot of calculation power. and we move the goalpost. And we will be moving the goalpost in the future as well. We might never actually reach what everybody would agree is real artificial intelligence or artificial smartness. The Deep Blue machine, which beat Kasparov in 1997, the computing power of that machine was 11 gigaflops. The phone in your pocket most likely has something like 700 gigaflops. So 70 times the power of Deep Blue. Your phone is 70 times faster than the computer which beat Kasparov. Think about that. And think about how much more powerful our devices will be in 20 years' time. Because this is only accelerating. We've only seen the very beginning. And I believe that the upcoming machine learning and artificial intelligence revolution will start from self-programming programs. From programs that are able to write programs. And that's not hard to do. I've actually written a program which wrote programs already years ago. The programs it wrote really sucked, but they did compile, and you could run them. And you can, imagine that if you just keep on making it better, it gets closer and closer to my level as a programmer. And then one day, it's close enough that it can start making better versions of itself. And then it will bypass me. And then it will skyrocket. Because it's going to make a better version of itself, which is going to make a better version of itself, which is going to make a better version of itself. And we will end up with super intelligent programmer, which means that every programmer on the planet is immediately out of a job. Because we don't need programmers anymore. And this could actually happen. Sounds crazy, but there's plenty of research papers about exactly this already out there. And there's several startups already selling self-programming programs, or selling programs which will write other programs. Then another thing which is changing right now is the future of money. Now, we all know about cryptocurrencies, things like Bitcoin or Ethereum, designed by Vitalik Buterin right here. But I don't believe that cryptocurrencies will kill banks. I think we will still have banks in 20 years. We will not be needing banks to move money. We will be using blockchain-based technologies to move money. But we will still be needing banks for investments or loans or things like that. But banks will lose a big part of their business. But right now, as we have many times seen, cryptocurrencies are mostly used to buy drugs online in Tor hidden services or to ask ransoms from ransom Trojan victims. In fact, there was yesterday a great talk from Google outlining the amount of revenue ransom Trojan gangs make. The combined revenue of ransomware gangs right now is over $1 million a month, constantly. $1 million a month, every month, is the profit made by ransomware gangs. And by the way, that's tax-free. So let's go back to this Petya theory. It's a Petya ransomware Trojan on an ATM, which I find interesting, because normally you go to ATM, and ATM gives you money. In this case, the ATM asks you money, right? And we're seeing cryptocurrencies being used in crimes which have nothing to do with computers. We've already seen several cases of real-world kidnapping, where people are kidnapped and the ransom is demanded in Bitcoin. And of course, the reason why Bitcoin or Monero or Zcash is being used by criminals is that they believe they can't be found if they use online currencies. So why is it hard to find criminals when they use online currencies? Well, let's take a look at the Petya wallet. Petya happened a month ago, exactly a month ago. All the ransoms were paid to this one single wallet, and around 2 weeks ago, the owners of Petya started moving money away from that wallet. Initially, they moved it to 6 wallets. And then they started moving it further from there. Let me just play this to you. You'll see how the money starts going from one address to another address, from one wallet to another wallet. And very quickly you realize that it's very hard to follow where the money goes. This is the basic problem in monitoring blockchain-based money movements. And then we have many other problems to worry about. If we think about the future of technology as a whole, what we really think about is future of security, right? And one thing that's going to have a major impact on our work over the next 20 years could be quantum computing. Now, quantum computing is a tough cookie to crack. We might not have a real useful quantum computer in 2038, but we already have prototypes. IBM actually has a 17-qubit quantum computer available right now. These actually exist. But to have them work at the level where we would actually start doing full-scale simulations could actually be further away than 20 years. But one thing that could happen is have enough functionality in quantum computers to start to factor primes. Because quantum computers would be well suited for factoring calculations based on primes, which means breaking every encryption system based on multiplying large primes with each other, most notably RSA. And that's important because almost all SSL certificates or TSL certificates today are on top of RSA. So imagine one day waking up and every single SSL encryption system on the web is broken. No more secrets. This could actually happen. And then we would have to recover from that, which we could do by going to encryption systems which are not based on multiplying large primes with each other. They do exist. Super singular elliptic curve crypto would be one, or lattice-based crypto. So we could actually recover from there. Another problem we have to solve is the problem of securing these IoT devices. Because clearly the vendors are not going to fix this problem by themselves. And you cannot secure your washing machine by installing an antivirus. So what can we do? And I actually believe we are right now seeing the birth of a whole new security product category. Security home routers. We actually have one ourselves. We call this F-Secure Sense. The basic idea is that the devices you can't secure with software, you secure from the network. You create a separate new network in your home for IoT devices, then you connect them all to this separate network, and they are secured as well as we can through the network. And we've already seen McAfee, Symantec, Bitdefender, and some other vendors entering, or at least announcing that they will enter this market. This could be one of the big shifts in security products in the near future. So what about the future of conflict? The worst examples of what could happen we've seen in Ukraine. Obviously, Petya was one, and 2 years ago, the attack against the electricity grid provider Prykarpatto Oblenergo is, I suppose, the most famous one. But if you think about what could be done by hacking systems when you're targeting a whole country, turning off power is pretty bad, but it could be much worse. One thing that I worry about is targeting consumer devices and making them fail physically. And when I mean physically, I mean actually, for example, making them catch fire. And this is doable because our devices are programmable at microcode level. Here's a picture of a GPU catching fire, just purely based on software. So you can imagine a conflict when one party of the conflict sets fire to every home in the country that's at the other end of the conflict. Technically could be done. And that's a scary scenario, if anything. Which brings us to the future of war. Now, wars today are being fought with drones. And drones are still being controlled by human beings, mostly for, I don't know, philosophical reasons. They could perfectly well fly themselves. And we already have artificial intelligence being used in other kinds of weapons as well. Can we turn on the audio?
Surveillance and security system with the key. Samsung's intelligent surveillance and security system with the capability of detecting and tracking as well as suppression is designed to replace human-oriented guards, overcoming their limitations.
They are designed to replace humans, overcoming their limitations. And that's made by Samsung. So Samsung makes, they don't just make displays and phones, they actually make guns and tanks as well. Which gets us to the project which was underway already a couple of years ago, the Energetically Autonomous Tactical Robot, which is a battlefield robot which is able to operate without fuel. It uses biomass as fuel. And then it takes you a while to figure out what actually that means, which takes us to the perhaps the best press release done by a company ever. The company behind this put out a press release where they say, "We completely understand the public's concern about futuristic robots feeding on the human population. But that is not our mission." So, machines are getting smarter. And if you want to avoid one mistake, I'll give you an advice. Whatever you do, don't kick the robots. Don't kick the robots. Because one day, the robots will be smart enough to go to YouTube to watch videos. And they will see this. And they will be angry. So, should the car drive over the father or the daughter? Well, I don't know. But these are the problems, these are the questions that we have to find answers for. Because we are the ones that have to fix all this. We who work in security. Because our work is no longer to secure computers. Because today everything runs on computers. Your work is not to secure computers. Your work is to secure the society. Thank you for your work. Thank you very much.